This is our fifth lesson. Now, in our third and fourth lesson, we did look at the explanation and how to use the SO to solve examples on trigonometry. In our fifth lesson, we'll be looking at applications of trigonometry. Applications of trigonometry. So, applications of trigonometry, we can take a clue from how one will be able to reach a height above him, either painting a wall or adding blocks to uncompleted structures. Now, we always use what we call scaffold to reach a height of which someone painting a wall cannot reach. So, we have what we call ladder and wall applications. And so we'll be looking at a diagram which can be or the same as the diagram we used in our previous lessons. So I have this as my diagram. I will name this side as a wall. Then the base as a foot. Then the slight height has a ladder. The ladder leans against a wall. So this is a typical application of trigonometry. Where we have a wall, I can name this side as A, B, and C. Now, in the same way as we did in writing the formulas for trigonometry, we can do the same for this one, that is the applications of trigonometry. Sometimes you can be asked to find an angle in any side of this diagram. You can also find the side, that is the side name, the wall, the foot, the ladder, any of the side you can ask to also find. If you are asked to find any of the side, you can apply the formulas of the Pythagoras theorem. If you are asked to find angles of this diagram, you can also use the formulas we use in the previous lessons, that is either the SO or the Ka or the Twa. Now, if I put an angle at C, and you are asked to find theta, we said in our previous lesson that where the angle is directing to or pointing to always becomes the opposite. So we have this side as the opposite. Where we have the wall becomes the adjacent, and then where we have the ladder becomes what? The hypotenuse. Now if I'm to find the side of the opposite, that is the AB, I'll write line AB square equal to the longest side represents the ladder, which is the hypotenuse. That will be BC square. Since the BC is the longest side and that is the hypotenuse, we have made AB the subject, which is the opposite, representing the foot of the diagram, minus where we have the wall, and that is the adjacent. That will be line segments or line AC squared. So this is the formula to use when you are asked to find the foot of this diagram. Now if you are asked to find the angle, you look at where the angle is pointing to. If you are either asked to find the angle, sometimes you will be given either a value for the hypotenuse or a value for where we have the wall, that is the adjacent, or the foot that represent the opposite. Now if you have a value for the wall, and the value for the ladder, that is the hypotenuse. It means that we go back and look at the slogan we used in our previous lesson. The first one was so ka twa. Now in this, you look at where I have ticked the wall and the ladder. It means that we have to find the theta and to use the wall and then the ladder. Meaning that you come here and look at where we have the ka, and that is adjacent over hypotenuse, meaning that our cos will be theta equal to adjacent over hypotenuse, and the side of the triangle is for adjacent is AC over hypotenuse BC. So to find theta, there is the formula you can also use, and to find the length of AB, there is the formula you can also use. Now let's take an example and see if we can determine the angle or any side of the right-angled triangle. Example 1. A ladder Okay, so this is our first example. A ladder leans against a vertical wall at an angle 60 degrees with the horizontal ground. If the foot of the ladder is 5 meters away from the wall, find the length of the ladder. Now in such questions, the diagram is not always given. You have to read to understand and draw the diagram yourself. So you read again and then draw the diagram. It goes by saying that a ladder leans against a vertical wall. So you all know that a wall always stands upright. So in solution, we have this as a vertical wall. A wall always stands on the ground. So this is the level ground or the foot. Then we have a ladder which leans against the wall. So from the top of the wall, draw a line to join the base of the ground, and that will give us the ladder. So you can name it A, B, and C. The base was given as 5 meters. So you write your 5 meters representing line AB. And the angle given was 60 degrees. It says that a ladder leans against a vertical wall at an angle of 60 degrees, means the ladder forms an angle to the wall as well, 60 degrees. We have to find the length of the ladder. Here we can refer to this one as the hypotenuse. So we look at where the angle is pointing to. I will draw an arrow to represent that it points to line AB. That becomes the opposite, and we are finding the length of the ladder. That also becomes the hypotenuse. So that also represents the other side, which is what? BC. So you're looking at the formulas we learned earlier on. We have so ka twa. So we have the opposite, we have the hypotenuse. So we can take the so and so katwa. So the so will be sine theta equal to, we have opposite as AB. So line AB over the hypotenuse, which is line BC. So theta in the question was given to us as 60 degrees from our diagram. So we have sine 60 degrees equal to, AB was given as 5 meters. So in place of line AB, you substitute it with 5 meters over line BC, which was not given, and that is the one we are looking for now. Now here, we assume that sine 60 degrees is over 1. So what you can do is to do cross multiplication. In cross multiplication, sine 60 will multiply line BC. So sine 60 degrees times line BC, which is equal to 1 will also multiply 5 meters. Now since we are making BC the subject, we can divide through by sine 60. So sine 60 cancels sine 60, leaving line BC equal to 1 times 5 will give us 5 meters. And sine 60, from a calculator, you press sine and 60 degrees will give us 0.5. 0.5 is also the same as 1 over 2. So I can make it 5 meters over 1 over 2. So here the 2 will multiply the 5. So our line BC will be equal to 5 meters times 2 over 1. So line BC equal to 5 meters multiplied by 2 will give us 10 meters over 1. We know that every whole number is over 1, so therefore line BC will be equal to 10 meters. That is the value for, or the height of the ladder. So you can also write therefore the height of the ladder is 10 meters. So in all, from our question given, that is the value for the length of which the question asked us to find, the height or the length of the ladder. I can also give you an example for you to try, but time is not on our side. So what I will do is that it's not on our side, so we take our last example and end the lesson for today. A ladder eight meters long, so our second example says that a ladder 8 meters long leans against a vertical wall. If the foot of the ladder is 3 meters away from the wall, find the angle the ladder makes with the wall, correct to the nearest whole number. So from here, as we did from our first example, we draw the diagram as we read to understand the question. So we use a vertical wall, and that was no value was given for the vertical wall. We have our baseline, and then the ladder leans against the wall. Now we said that from the question, a distance was given. If the foot of the ladder is 3 meters, that is from away from the wall. So I will name the sides of my right angle triangle as A, B, and C. So the distance between the wall and the foot of the ladder is 3 meters. The height of the ladder is also 8 meters. Then we say that we should find the angle that's the ladder makes with the wall, so that we can use theta to represent the angle. Now after using theta to represent the angle, we find the value for theta, that is the actual value that represents the angle. So we take a clue from the three ratios we did earlier on, that is the formula, the SOHCAHTOA. So where the theta is pointing to from the diagram is line AB, which is 3 centimeters, and where the H is also the hypotenuse. So you can take So taking a clue from the So, we have sine. The angle is theta. So sine theta equal to O is the opposite. From our diagram, the opposite side is AB. So line AB over line BC. So where we have the AB from our diagram is 3 meters. So sine theta equal to 3 meters over BC is also 8 meters. Now we can use the meter attached to the 3 to cancel the 1 attached to the 8. That will give us sine theta equal to 3 over 8. Now we have to find the value of theta, not sine theta. So we can divide through by sine. So sine 3 over 8 also divided by sine. So sine cancels sine. So we have theta equal to, we find inverse of sine. That will be 3 sine inverse into brackets 3 over 8. Now when you press the calculator for 3 over 8, so theta will be equal to sine inverse into brackets. From the calculator, it will give you 0.379. So take your calculator, press shift and press sine. Then the value 0.379 will give you theta equal to 22.489 degrees. But from the question, we were asked to write it to the nearest whole number. So you can say that, therefore, theta will be equal to 22 degrees. That is the value for the angle that's the leader makes with the wall. So I know all of you who understands it. So if there's a question you ask, if there isn't, we move on to the next aspect of this lesson. Now I'll try to post an assignment on my wall. So you visit my wall, copy the assignment, do it, and repost it back to me to mark for you. If there's anything you don't understand, as I gave my email address to you, the day you can chat with me or have a discussion with me is on Monday, 8 a.m. to 9:30 a.m. Thank you, and God bless you for coming for class and then to enjoy the lesson. We meet in our next lesson.